Now in this video we are going to discuss about numericals or MCQ type questions on SN1 reaction. First case, which is the more reactive of SN1? In all these cases, all are 3-degree alkyl halides: iodide, bromide, chloride, fluoride. Which is the answer? First is the more SN1 reaction than the second one. Second one is more than chloride. Chloride is more than fluoride, because we know very well the iodide is what? Better leaving group than that what? Bromide, which is better leaving group than that what? Chloride, which is better than that what? Bromide. This is the nucleophilicity order. Here carbon iodine bond length is more, bond energy is less, so therefore carbon iodine. See now here when we are taking that what? Bond length of carbon iodine is greater than that what? Carbon bromine, then which is greater than that what? Carbon chlorine, which is greater than that what? Carbon fluorine. So bond length, already we know that bond length is inversely proportional to bond energy, bond dissociation energy. So here this bond is easily broken, so therefore iodine can be leaved fast than bromide, chloride and fluoride. So therefore SN1 reaction is faster. Next, the second case. Now here also in the given case, all are 3-degree alkyl chlorides. But here what is given? Here this alkyl halide is given 3 molar concentration. Now this is given 2 molar concentration. This is 1 molar concentration. Now already we know that SN1 reaction, rate of reaction is directly proportional to concentrations of that what? An alkyl halide. More is the concentration of alkyl halide, more is the rate of SN1 reaction. So therefore more is the concentration, more is the SN1 reaction. 3 molar, 2 molar, 1 molar. So here more is the concentration, more is the SN1 reaction. Next, SN1 reaction, which is more favorable for this SN1 reaction? N-butyl chloride, secondary butyl chloride, tertiary butyl chloride, then allyl chloride. Now allyl chloride, see now what is a N-butyl chloride structure? Now N-butyl chloride structure means this is CH3, CH2, N means normal, normal means what? Straight chain. Butyl means how many carbons are present? 4 carbons are present. This is N-butyl chloride. Next one is secondary butyl chloride. C, secondary butyl chloride. This is the secondary butyl chloride. Secondary butyl chloride. Secondary butyl chloride. Next, another one is tertiary butyl chloride. Tertiary means 3-degree carbon. Now this is called as what? Tertiary butyl chloride. Next, another one is called as what? An allyl chloride. Allyl chloride means double bonded carbon, connected carbon. If it is sp3 carbon, then it is called as what? An allyl carbon. See now this is called as what? An allyl carbon. Now this is allyl chloride. Now which is more? So now whenever they are asking SN1 question means what is the SN1 reaction? First step, formation of carbocation by the ionization of what? Carbon halogen bond. So now this is carbocation is formed and the leaving group is leaving from the substrate. Next, now this is the leaving group, then the carbon halogen bond is broken, then 2-degree carbocation is formed. Next, tertiary, this is tertiary butyl chloride. Now this is tertiary butyl chloride. Carbon halogen bond is broken, then here what will be happen? A 3-degree carbocation is formed. Next, carbon halogen bond is broken and allyl carbocation is going to be formed. Allyl carbocation. Now among these, which one is more stable carbocation? Now 3-degree alkyl carbocation is more stable than that what? Allyl carbocation, which is more stable than 2-degree carbocation. Now 2-degree carbocation is more stable than that what? and 1 degree carbocation. So this is the order. So therefore, what is the order of reactivity? Tertiary butyl chloride is more than allyl chloride. Allyl chloride is more than that what? Secondary butyl chloride. Secondary butyl chloride is what? This is the increasing order. This is the first reactive. Now this is the second one. Next this is the third one because 2 degree carbocation. Now this is the last one because of 1 degree carbocation. Now SN1 reaction, 3 degree carbocation is more stable than 2 degree. 2 degree is more stable than that what? 3 degree. Next, which of the following is hydrolyzed or solvated by SN1 mechanism? Hydrated or solvated by SN1 mechanism. This is methyl bromide, ethyl bromide, N-propyl bromide, tertiary butyl bromide. We know that SN1 is what? More favorable for what? A 3 degree carbocation. So therefore this is the answer. 3 degree carbocation is more stable. So therefore 3 degree tertiary butyl bromide is undergoing hydrolyzed or solvated is easily because 3 degree carbocation is more stable. Next, in this case, now the given compound is what? 3 degree added and given solvent is what? Water. Water is given. Water is given means it is a polar aprotic solvents. Polar aprotic solvents are favorable for that what? An SN1 mechanism. Now here it will give predominant product and it will give that what? Another product. That means this compound will give two products. What are those? A and B. After this, A is what? Predominant, then that what? B. Now take here. Now SN1 reaction means what? First arrange that what? Step number 1. Now here they given CH3 which is below the plane. Now phenyl is given which is above the plane. Now the given compound is iodide. Now SN1 reaction means what? This is the polar protic solvents. These polar protic solvents will break the bond between carbon and halogen. Then the carbocation is going to be what? Formed. Carbocation is going to be formed. Now this is called as a what? CH3. Now this is called as a what? Phenyl. Now this is the carbocation. Now here the attacking of nucleophile can be possible. Here water is acting as a what? A nucleophile. Now this nucleophile can be attacked either from front side or it can be possible from that what? Back side. It can be possible from front side or it can be possible from back side because the carbocation is having that what? A planar structure. So nucleophile can attack either from front side or it can attack from either back side or rarer side. Or it is also called as what? Nucleophile can attack from top side. Nucleophile is also can attack from bottom side, or side. Now for suppose if nucleophile is attacking from the front side, then what we are going to get? Here we are going to get C2H5. Now CH3 which is present below the plane. Now pH which is present in above the plane. Then here we are going to get that what? OH. Next one. If it is attacking from the back side, now C2H5. Whenever it is attacking from the back side, these groups will shift this side. Then we are going to get that what? CH3 and the pH and the nucleophile will be what? Attacking from the back side. So now this is called as a what? An Walden inversion. Inversion product we are going to get. This is called as a what? An Walden inversion. Now this is called as a what? An retention product. It is called as an retention product. Now already we discussed, always retention product is dominating that what? An Walden inversion. Why this is called as a what? Retention product means this reactant and this product, they are having that what? Same configuration. If it is R means this is R. If it is S means this is S. Otherwise if it is dextrorotatory means this is dextrorotatory. If it is levorotatory means it is also levorotatory. Next this is R means this is S. If it is S means it will become R. So inversion configuration we are going to get. So predominant product is called as a what? Retention, and the minor product is called as a what? Wall down. So this is predominant product and wall down. Retention product is the predominant product. Retention product is the predominant product. Next, another one is called as a what? And wall down inversion. Another one is called as a what? And wall down inversion. Next, question number 6. Now, which of the following is reacting with an aqueous KOH? What is the formula? Here, what is the leaving group is there, and what is not a leaving group? Halogens are the good leaving groups. Now, chlorine is there, bromine is there. Which is the better leaving group? Bromine is the better leaving group because carbon bromine bond length is more when compared to carbon chlorine, so therefore it is the better leaving group. So therefore here substitution will be what happened. See, now when we are taking that what? An aqueous KOH. Aqueous KOH means KOH is present in the water. It will give that what? K plus in aqueous medium, and OH minus is present in that what? An aqueous medium. Now this OH minus present in the aqueous medium, it is acting as a what? A nucleophile. OH is acting as a, OH minus is acting as a nucleophile, hydroxyl ion. So therefore it is the leaving group. No, so therefore substitution is happening here easily. So therefore we are going to get the product is this one. Okay, this is. Next, question number 7, which is more favorable for SN1 reaction. So now whenever they are asking SN1 reaction, first step is what? Carbocation. Carbon halogen bond is broken. So now I will write here itself. Carbon halogen bond is broken, carbocation. Next, carbon halogen bond is broken, carbocation. Next, carbocation. Next, carbocation, carbocation, carbocation. Now carbocation is stabilized by, see now here what group is present here? Now oxygen is containing that what? Lone pair. So therefore it is acting as a what? Plus M effect, mesomeric effect. Now here double bond carbon, connected carbon, sp3 carbon means it is called as what? Alpha position. Here 3 alpha hydrogens are present. So therefore it is acting as a what? An hyperconjugation. Next, this is benzyl carbocation. Next, this chlorine will act as a what? Minus I. Now this is acting as a what? Minus M, because cyanide. Now this is also acting as a what? Minus M, minus I. Here also it is also acting as a minus I, but compared to inductive effect, mesomeric effect is dominating. So therefore we are considering what? Mesomeric effect. Now which carbocation is more stable? And before video we studied carbocation is stabilized by an electron donating groups, or it is stabilized by an resonance effect. It is stabilized by an resonance and destabilized by electron withdrawing groups. See now here, now plus M effect means electron donating, electron withdrawing, electron withdrawing. Minus M effect of NO2 is more than that what? Cyanide, chloride. So therefore here hyperconjugation, here mesomeric effect, which is dominating. Always a resonance effect or mesomeric effect is dominating than that what? And hyperconjugation is dominating than that what? An inductive effect. Resonance effect or mesomeric effect. So therefore mesomeric effect is dominating than that what? Hyperconjugation, which is dominating than this. Why compared to this? This is more favorable for SN1 when compared to this one means because here electron withdrawing groups are present. So therefore now minus I, minus M. Okay, now minus M is more withdrawing power when compared to minus I. Now minus M, minus M. Cyanide is having weak minus M compared to an NO2 group. So therefore it is more favorable for SN1 reaction. Next, another one is, see now this is halogen is attached at what? Bridged carbon. Next here halogen is attached here. Now Whenever they are asking SN1 means you break the carbon halogen bond and arrange the carbocation. Now this is the carbocation. Now this carbon halogen bond is broken. At this position, carbocation is formed. This position, bridgehead position, there is a carbocation. So at this position, carbocation is present means this is not a planar structure. Is not a planar structure. So therefore this compound is highly unstable. This compound is highly unstable. So therefore this is more favorable when compared to this one. At bridged position, carbocation is present. Bridgehead position, carbocation is present. That is always unstable because of a non-planar structure. That carbocation is not stabilized. Attacking of nucleophile is also difficulty. So SN1 reaction is not favorable. Next, another one is. Now this one. Here also you can break the carbon halogen bond, then arrange the carbocation. Here also break the carbon halogen bond, arrange the carbocation. Arrange the carbocation. Now which one is more stable?